Good morning. I'd like to welcome everyone to this panel discussion on nuclear energy as part of the Future Energy Festival hosted by the Energy Futures Lab, the Imperial's Global Energy Institute. My name is Mike Bluck and I'm the director of the Centre for Nuclear Energy, and I work in various areas of nuclear reactor technology and have done so for the last almost 20 years. So we've put together a panel covering a range of nuclear-related expertise at various points in their career or studies. And I'm very pleased to say we have Katrin Davis, a reader in mechanical engineering, with a focus on structural safety of nuclear reactors. Tom Griffiths, a PhD student studying the economics of nuclear fusion. Mercedes Baxter Chinnery, a PhD student studying nuclear waste materials. And last but not least, Maria Bickley, an undergraduate in mechanical engineering studying nuclear. So we want this discussion to be as interactive as possible, so please get involved by putting your questions in the Q&A box on the right-hand side of the screen. This session is being recorded and will be made available on the Energy Futures Lab YouTube channel in due course. If you would not like your name to be on the recording, you can submit your questions anonymously. The event will last no longer than an hour. We'll try not to overrun. So just a few words from me before we start. The title of this panel is Where Next for Nuclear? And that's a very important question to ask at this point in time. COP26 has agreed a need to reach net zero by 2050. By far the greatest contributors to CO2 emissions are the industrialized nations, currently heavily reliant on fossil fuels. Attempts to agree a transition to low carbon electricity have been difficult and arguably unsuccessful. Note the phasing down rather than phasing out of fossil fuels agreed at COP26. Many, if not all, of these countries have embarked on substantial installation of renewables. Despite this, it has not resulted in an emissions trajectory consistent with the net zero by 2050 target. The clearest, perhaps, but not the only example of this is in Germany. Huge renewable capacity, but still relies on fossil fuels and has CO2 emissions worse than, for instance, the UK. Plainly, in and of itself, installing renewables does not get us to net zero. The reason for this is well known, it's intermittency. Those opposed to nuclear maintain that a better, cheaper solution to intermittency exists as a combination of demand management and storage. However, neither of these technologies have been developed at scale and rely upon hoping that the necessary technologies are around the corner. There is a risk in this position. The current solution to intermittency is fossil fuel. As such, and paradoxically perhaps, the true cost of a renewable grid is currently determined in large part by the cost of fossil fuel. Gas and coal have historically been cheap, of course, so renewables look cheap. Nuclear, on the other hand, provides reliable low-carbon electricity and is a well-understood technology that has produced most of the world's carbon-free electricity for decades. Currently, there are 420 reactors in operation. Nuclear power plants lend themselves to cogeneration and deep decarbonisation. All produce steam as waste, which can be used for district heating and green hydrogen production, which also makes them very suitable for matching with intermittent renewables. At face value, however, nuclear is very expensive. And this is perhaps the most significant reason why the expansion of nuclear has been limited, at least in the West, with the notable exception of France. There are large upfront costs and unfavourable funding mechanisms, essentially political decisions, particularly in the EU. This contrasts with expansion of nuclear in China and Russia. In the UK, our existing AGR fleet are reaching the end of their life. There is an EPR under construction at Hinkley Point C and plans for an identical reactor at Sizewell. These have all been criticised for their cost. There are also political and ideological factors. Countries such as Germany, Austria, Belgium are shutting down their reactors. Cost, of course, is relative. Recent events have shown what happens when gas prices rise, as they are likely to continue to do so, or there are concerns over security of supply. These concerns are very much behind recent UK decisions to fund the development of SMRs, and there are recent new build agreements in Poland, Ukraine, Turkey and elsewhere. There are other issues, of course, waste, safety, build time. I'm sure that these will be picked up in the Q&A. With that, we'll move on, and I'll ask panel members to briefly introduce themselves and what they do. So first, I'll ask Katrin if you can introduce yourself.
Hi, I'm Katrin Davis. I'm a reader in structural integrity of alloys in the Department of Mechanical Engineering at Imperial College. And I work on assessing the safety of nuclear reactor components, components such as reactor pressure vessels and historically in advanced gas co-reactors, pressurized boiler components and steam piping. What we do effectively is through the development of advanced experimental testing and modelling techniques, we're able to support plant operators with the development of component lifetime assessment codes. Of course, this enables them to deliver safety cases to ensure the safe operation of nuclear plant components with appropriate levels of conservatism. And of course, we do this by developing a fundamental understanding of materials' potential damage mechanisms. So we achieve this by developing in the laboratory plant representative testing techniques for materials. For example, for the advanced gas core reactors, historically, what we've done is do things like derive laws to determine the initiation times of any potential cracks that could be there and how they would grow. And of course, this ensures that cracks don't grow to any unsafe levels during operation. Also, we work closely with non-destructive valuation and to develop techniques to inspect components and damage, and of course we develop structural health monitoring tools. Furthermore, we develop and validate models to simulate the component's behaviour during operation to predict the remaining lifetimes of such components, considering a range of damage mechanisms. And these models can be used to perform what-if scenarios to ensure the impact of, for example, any postulated defects in components are fully understood, even though it's highly unlikely that the majority of these components would be actually present in components. But therefore we can ensure that there'll be no adverse consequences to them in the likely event if they did exist. So the experimental and modelling techniques we develop also provide tools to enhance the design of components for new nuclear fission as well as nuclear fusion reactors. And these tools will support the optimization of designs to ensure safety and also with the intent of reducing cost in future.
Okay, thank you, Katrin. Tom, could I ask you to give a brief introduction?
Yeah, sure. Thanks, Mike. Yeah, hi everyone. I'm Tom. I'm a second-year PhD student here at Imperial as well in the Department of Mechanical Engineering. I actually have a background in geology and made kind of a transition during my undergrad or after my undergrad to a master's in nuclear engineering, and I did that at Bristol, and yeah, now I'm doing a PhD at Imperial, as I said before. I'm looking at nuclear fusion and specifically looking at how fusion can be used in a commercial way. So lots of PhDs or lots of research at the moment in nuclear fusion is based on R&D, looking at plasma physics and engineering concepts that need to be understood in order to make fusion viable for the grid, but some aspects that haven't been so deeply looked into and that are needed for commercialization are things like the economics of it. So, you know, how much will fusion cost, and how does that compare to other technologies? And obviously, as an unrealized technology, there's lots of uncertainty in that, and lots of my research is looking at how you can understand that uncertainty and how we can make it more of a kind of a viable option for investors to go for in the future, and maybe not just as an electricity resource as well. There's obviously lots of other sectors that fusion can be useful for. Actually, energy consumption, the electricity side of the sector only covers about 1/3 of the world's energy consumption, so there's lots of other areas that need to be decarbonised. If there's a hydrogen economy, for example, as has been mentioned before, the fusion could be a good candidate for that, due to the high thermal capacities of the reactors that are going to be used. But again, there's lots of different reactors that are kind of looking to leapfrog those in the public sector from the private sector. And yeah, a lot of research needs to be done to see whether or not those can be used in certain applications. And yeah, that's what my research will be looking at.
Okay, thanks, Tom. Mercedes, did you want to?
Yes, thanks. Hi everyone, I'm Mercedes. I'm a third-year PhD student at Imperial in the materials department. I did my undergraduate degree and master's degree in engineering, specialising in civil towards the end. I'm now based in the materials department, but also in the civil department. I'm looking at encapsulating waste. So a lot of the waste from past nuclear plants, especially the original civil nuclear plant, which was based up in the north near Sellafield, called Calder Hall. They will a special type of reactor called Magnox reactors, and I'm looking at using that waste that has been stored for 60 or more years now in a cement to try and reduce waste volume. And there are lots of different people looking at different types of cement that it could be encapsulated in or could be used as an encapsulant. I'm currently looking at a new type of cement which uses it and silica. So normal cements have a calcium-based metal, calcium oxide usually, and silica. And when they react together, they can form that strong cement that we use everywhere. What I'm looking to do is see whether magnesium can be a substitute for calcium. Obviously, for those of you who know the periodic table, they're in the same group, so they should have similar properties. So it's looking and seeing whether that's a viable alternative.
Okay, thank you, Mercedes. And finally, Maria.
Hi everyone, my name is Maria. I'm in my third year of my undergraduate degree at Imperial College. For my first 2 years, I only learned about mechanical engineering, but fortunately Imperial offers a course which does mechanical with nuclear engineering. So I'm on that track right now. I've currently been learning about nuclear engineering for the past 7 weeks, and I found that really interesting. One particular project I'm doing for Mike is the scaling of nuclear thermal hydraulic rigs, which has been very interesting. So that involves looking at small prototypes and small models for nuclear rigs and finding different ways and approaches to scale it up. And we do this for purposes of safety, cost, and mostly an efficient allocation of resources. So I've learned a lot, I think, in a very small amount of time, and it's been really encouraging just beginning to decide on a career in the nuclear industry, especially after the recent news with COP26 and everything. So that's been really exciting.
Okay, thank you, Maria. Right, so that's us. I think now we head into the questions, if I'm right, the Q&A session. So I'm looking down the questions so far. Please do like a question if you want to emphasize your interest in a particular question. At the moment we haven't got any, but that's we've got a couple of questions on the Q&A. First one is, what about batteries, DSR, hydrogen interconnectors, etc. for non-fossil fuel flexibility? I don't know if any on the panel want to take that. I'm happy to give it a first go. I think it's a very good question. I think clearly batteries have a role to play in the energy system, and so do other potential fuels, if you like hydrogen, and the use of interconnectors is already there in balancing the grid. I think the issue is one of scale for batteries. There are no grid scale batteries. There's some very large batteries, but they are simply not in at a technological nor cost level to make any contribution to grid level storage of the kind that is needed for a few days of lull. Hydrogen is a very good point, and I think hydrogen is a promising vector. However, again, for storage, hydrogen has surprisingly low energy density. So again, it's not necessarily what you use for grid level energy storage, but of course it is a vector for a number of fuels that could be used, either fuel cells or indeed synthetic derivations of hydrogen, green ammonia, and so on. So, and as I say, interconnectors are all very good, but you can get quite regularly continental size lulls, as we're actually seeing right now. So if you look at Germany's wind production, it is down at about 10% of what it should be, as is ours, because it's a continental lull. And again, it's not an issue that there is one technology that wins. It's really about a combination of technologies, I think, is the future. I don't know if anyone else wants to say more on that.
No, I was just going to say, were you going to say, Mike, that batteries, etc., you know, it's not the solution, it's just part of the solution. It's not just one technology. We need to look at the sort of full range and have them all working together.
Yeah. Okay. The next question we have is, are SMRs the future of nuclear? I know this isn't Tom's a fusion guy, but he is looking at small fusion. I'm going to ask Tom I suggest Tom sort of says what he thinks about whether SMRs are the future of nuclear. He may be really annoyed with me right now, but go ahead.
No, that's fine, Mike. I'll take the question. So yeah, SMRs, obviously, I think a lot of issues that you're currently seeing in the news, especially in the UK, around large-scale fission plants, such as the one at Hinkley Point C and Sizewell, are that basically they're not. You can't create like an industrial supply chain to manufacture them. You can't go to get a manufacturing process together to produce the same part for each iteration of a new plant. So with SMRs, the idea being that they're modulars, that you have to obviously intermittently replace certain components due to just the lifespan of them, or when you're manufacturing new ones. And in there being a modular part of it, it means that you can introduce that kind of that infrastructure with manufacturers. And if you can do that, then you can bring down the cost, and it's just a simple kind of economies of scale thing. And as I said, yeah, with the current reactors that are in place, you can't do that because every new reactor, or every reactor that's being built, is a completely new design. So recently there was, if you might have seen in the news, that there's been some investment from the government into Rolls-Royce to procure some small modular reactors for the UK. Currently Rolls-Royce, they're not involved in, I don't believe, in any civil nuclear side of the energy industry for the UK, but this will be a new step for them. I think probably a part of Mike will be able to expand on this. Part of the reason that they would have been selected to do that by the government and would have put their hand up for it is that they have experience in making small modular reactors, and that's a massive advantage. In terms of fusion, again, lots of reactors that are being designed by private companies at the moment are looking towards a much more modular design. And again, that lends itself purely to the fact that you can have that manufacturing capability where you can introduce economies of scale and bring down the costs. When you make more of something, naturally the costs come down.
Okay, thanks, Tom. Right, we are getting a few questions in. Right, I'm trying to balance this with let me try and balance this with a question that's got a few likes. An Imperial report showed the cost of nuclear would need to halve to compete with renewables. How likely is that? Mercedes, I mean, I know you're a waste person, but you do a lot of outreach. Any thoughts on that?
I mean, it's not just about the cost. So with nuclear, and a lot of what I've seen from outreach is people are opposed to nuclear because of the considerations with regards to safety and all the negative conceptions of what nuclear entails. So I think before we start talking about costs and things like that, we actually need to look at outreach and how people are aware of what nuclear is and how safe it is, and debunking all those myths that people have from past incidents and things like that, and showing that nuclear is a safe thing that can be around in the UK. I think that's probably the first thing. And this may not be a popular opinion, but I think the other thing is also time frame. So obviously one of the big things is time frame. This is, you know, people who are going to be putting nuclear power plants into play in the UK are generally going to be, like, especially big power plants, are going to be government, you know, okayed. And whilst the government has about 4 or 5 years in power, and then it could potentially change. Power plants at the moment take so much longer to be built. I mean, there's one being built, the French are building a couple, and they've taken over 5 years. Some of them are almost at 10 years now. So no government is going to want to start that without being able to have it finished and then enjoying the rewards from that. So I think that's something else that needs to be looked at. Obviously, the cost is absolutely massive, and one of the things obviously is that that's privatised. So actually maybe looking at other ways to fund it, whether that be through the government, and looking at ways to bring the cost down are important. And I think that will also come if we could reduce the time frame that it needs to be built and things like that. So I think there are kind of lots of different aspects to actually looking at promoting nuclear, cost being one of them, but there is a lot more to be considered.
Okay. Thanks. We've got lots of questions coming in, and so I'm going to have to pick and choose. So I'm looking at some of these. Let me choose one. So one is the possibility of integration between all types of energy resources. Let me answer that one if I can be so bold. What do you think about the possibility of the development of renewable energy and electricity without ignoring of nuclear and other traditional energy? Well, I think the answer, as we've said before, is that it's not one solution for things. I think that integration is an issue, but as we look forward, and I think I'm picking up another question here that I think also falls into this, which is the question of sorry, I'm sort of trying to find it now, of having to do deep decarbonisation, which involves decarbonising heating and manufacturing. And I think this actually plays quite well. There's an issue that is usually claimed with nuclear reactors is they supply baseload but can't follow or load follow. I think that in the future, with vectors such as the production of hydrogen or district heating, then there is a route to nuclear producing its baseload most effectively. I should also say that it's a bit of a myth that nuclear can't load follow. France has 80% nuclear and it load follows. So it's not ideal for a nuclear reactor. There's no reason it shouldn't. Right. Okay. Another one for Mercedes, I think, if I can. A question from Yvette: if nuclear power has become widespread throughout the world, what would be the implications of storage of large volumes of nuclear waste?
So I'm looking at intermediate level waste. So that's the decommissioning of plants, also the waste that's kind of around the nuclear fuels. So obviously there is a lot of that waste, and one of the easiest things to do in terms of looking at waste encapsulation is actually just everybody to have very similar nuclear power plants, so we're getting very similar waste. So one of the big problems, or one of the problems that we will face in the future, or is currently being faced, is the fact that a lot of the waste is different. So we started out with Magnox reactors, so they're magnesium non-oxidizing. That was the cladding around the fuel. That's all been stored for a very long time and actually probably should have been dealt with at the time. 60 years ago, they weren't worried about the waste and what they were going to do with the waste. And that's now become a larger problem for now, for us to deal with. But obviously with that, we've realised that actually we need to look at how we're going to deal with the waste as we're building the plants. It's not something that we can think about 30 years after we've built it. It's something we need to consider when we're starting that production. So that's one thing. So trying to build something very similar, so we're having similar waste we can encapsulate. Obviously, all long-term storage will be for intermediate level waste and high level waste. So things like that will go underground. So we need to find somewhere underground that we can store that. That obviously won't impact the surface, other than we'll have to have a way to get down there. And also we need to think about where we're building that. Obviously the UK is very good in terms of where we could build an underground storage facility, because we don't lie on any fault lines. So the US and other parts of like Japan and places like that, where they have fault lines, they have to be really considerate about where they would be storing their waste, because they have to make sure that it's going to be safe for a really long period of time. We're quite lucky in the fact that we don't have any issues like that. We could build it basically anywhere that would take it. So we should be fine in terms of building that geological disposal facility. But obviously it's just making sure we're keeping that waste volume to a minimum, and also we're making sure it's safe for a long period of time. We're storing it safely, securely.
Okay, thank you. And it's also important to note that when people say large volumes of nuclear waste compared to the waste due to almost anything else, it's really small. It's tiny. Most of the nuclear waste could fit in a cube not much bigger than a few houses of high-level waste. So it has to be borne in mind, but nevertheless it's a factor. But I have a question that one for Maria, I think, if you wouldn't mind. It's moving forward. I think I asked this because you're sort of comparatively new into this, so have probably a better view of this. Moving forward, in the panel's opinion, how can we change the public perception to become more positive on nuclear as a stopgap solution for the current energy transition? Because right now, even with modern advancements, the public is still stuck in a Cold War mindset.
Yeah, I think that's a really good point, especially when now I'm applying for jobs and internships, and a lot of people's reaction to applying for jobs in the nuclear industry is exactly that, just a negative perception of nuclear energy. I honestly think it literally boils down to, I know Mercedes was saying that she does a lot of outreach, but I think it boils down to educating people properly, because a lot of these opinions that people have are misconceptions. People look at nuclear and look at recent incidents, which were extremely unfortunate, but I think after learning about nuclear for a while, you can really see how the level of safety requirements in designing those reactors and how specific they are. And so I genuinely think it really just comes down to educating people and making sure that they understand the effort that goes into the safety design.
Yeah. Okay. Katrin, we left that on safety design. You work very much on the safety. Do you think people's mind is very much focused on safety as being a big issue?
Probably some sort of public think about safety in a sort of negative way, but of course, when you work in the field, you know how much research is actually done to ensure safety.
Yeah.
So I guess people don't necessarily see all the work that's done in that field on safety. That's not necessarily done to the same extent in other fields. So I guess they only see sort of one negative aspect, not all the positivity behind the safety aspects of nuclear. Okay,
great. Right, I have one for you, Tom. If we can move over, most of what we've been talking about has been fission. We've got a fusion one. Tom, what is the time frame for nuclear fusion? Say 1 to achieve a Q above 1, 2 to actually produce electricity, and itoplasma is several years away, etc. Demo even further away. Do you believe the breakthrough will come from public effort or private initiatives? This is your thing, so Tom.
Yeah, it really depends who. Yeah. Well, okay. So I'm there's a lot riding on this answer then. It depends who you ask, so I'll deflect it in that way. Basically, there's been a lot of in this year alone. I think I've seen more kind of kind of news articles from stuff like Bloomberg based around like fusion just around the corner than I've ever seen, and I think that's because a lot of private sector companies that have been kind of keeping their reactor designs secret have now been unveiling the research that they've actually been doing. Recently there was an experiment that happened at NIF, which is the one of the laser facilities in the US, I think, and that achieved that they submitted results for a Q that was coming towards 1, I think. Before that, I think the only fusion experiment that has tried to get that has submitted results for an experiment they did towards Q was for JET, and I think that was in like the late 80s or something, and that achieved a Q of 0.67. So in terms of when we will get fusion ignition, lots of companies and especially private ones, and you can kind of answer this question almost in one go, have, you know, they've received private investment predicated on the fact that they will achieve commercial fusion by a certain date. So a company that sponsors me, Tokamak Energy, they're based in Oxford. They have a roadmap that says that their reactor will be producing electricity by 2030, so that's 9 years. There's an argument to be made that certain private companies have to be optimistic in a lot of their timescales in order to receive investment in the first place. But there's a real race now. So there's lots of companies that are doing various different ways of doing fusion as well. So Tokamak Energy, who sponsor me, are looking at tokamaks. So that's superheating a plasma of fuel and containing it magnetically in a kind of donut torus shape. But then you have other methods that are being used as well. There's something called inertial confinement, which is where you have a small ball of fuel and you fire very high-powered lasers at that. That was what was being done at NIF, and that's how you achieve fusion in that way. You achieve that high temperature through those lasers. And then there's also other methods which kind of use a combination of both inertial magneto confinement methods. A company that's doing that is General Fusion. They are a Canadian company which have then since said that they're going to build their latest reactor facility in the UK. So the UK is like a really big hub for fusion at the moment. There's lots of exciting stuff going on in that respect. And yeah, so I think we've covered Q on there. Then the time scale. Some say 2030. In terms of who's going to do it first between private and public. If you're going to ask me, I think it would definitely be a private one that probably produces electricity first. ITER, which is the private investment or the private enterprise going on in the south of France, it will definitely do lots of important fusion experiments. It would look at 6 different designs of breeder blankets, which are obviously really integral parts of fusion reactors. But it won't produce electricity for the grid, and the reactor that will do that is DEMO, and that's the next iteration of the publicly funded fusion realm. There's in the UK though, public fusion. There's STEP. They've just announced a new kind of pathway for the UK for fusion in that regard, and that follows like quite a similar design to Tokamak Energy's spherical reactor. And again, I think they're looking to produce commercial fusion somewhere in the 2040s. So it depends who you ask. I think I covered everything there. Might remind me.
Yeah, I think you did, so with some very big error bounds on that. As I think it's true to say, fusion has always carried that slightly unfortunate tag. But there's a lot of developments in there. This is very true. Right, I have a couple of questions. Probably one that the energy. Okay, so this is a question that I sort of alluded to in the introduction. It's from Anonymous. It's the energy system needs to be net zero by 2035. Okay, if I accept that. Given how long it takes to build a nuclear plant, would we not be better off looking at other sources that can be rolled out more quickly? I think let me answer this one. Firstly, given how long it takes to build a nuclear power plant, it doesn't always take that long. Sizewell B was a PWR, and we built that in 4 and a bit years in the early 90s. I agree. You can't deny that the EPRs being built have been delayed. However, there's no intrinsic reason, and we have to remember that France went from nothing to 80% nuclear in 20 years. So, you know, to a degree, we, you know, that's not saying that it is easy to do, but that it is doable is just undoubtedly. It doesn't quite get us there by 2035, but there's no doubt that given the right, if you like, funding and the right approach, and again, I point to France in this one, that in a couple of decades you can essentially make your grid nuclear. Now, we're not asking that. We're asking for nuclear to provide a significant amount. Yeah, this is about working with renewables. So the alternative, as the question said, would we not be better off looking at other sources that can be rolled out more quickly? The question is, what sources? There are no other obvious sources. If they can be, they have to exist before they can be rolled out. So that's my response to that. So thank you for indulging me. Let me see. We have a number of questions on SMRs that I want to just sort of get through. So and I'll answer them very quickly. So there's whether SMRs can fit into the UK power system, the baseload or peak lopping. In general, they can. They have less inertia, so they're easier to load follow. Another question was, are the UK SMRs, Rolls-Royce SMR, are they the same as the sub-reactors? No, they're both PWRs, the sub-reactor and the SMR. Other than that, they have nothing in common. Okay, they're very, very different. Third question: can they go into an aircraft? I like this one. In the 1950s, it was the US did put a molten salt reactor in an aircraft. Okay, it was a dumb idea. Okay, they didn't drive the aircraft. They just made sure that they put a molten salt reactor in an airplane and flew it around. Okay, so nobody really knows why, but if you go to Idaho, to the EBR-1, the first functioning reactor in 1951, sitting outside of there is a molten salt reactor that they put in an airplane. And the lesson there was don't do it. Okay, so that's hopefully that's put to bed some of the SMR stuff. Let me have a look, see what we have. Okay, so again, there's a few more questions on if you like the time. So if we need to switch to electric vehicles from 2030, about this time to build nuclear plants. And again, you know, I wouldn't have started from here. I'd have carried on building Sizewell Bs, frankly, in the 1990s. We are where we are, and so there is a. I think again, this is about a grid that is mixed using the right sources. So we don't have to build an entire grid of nuclear. Nobody's suggesting that. But the benefits in terms of security and cost of some baseload, or at least something that can fill in, address the intermittency, has been made more clear over the last recently than it ever has been, and it will be increasingly clear. Okay, let me go back to some questions instead of talking about things. Okay. This is a good one. Leonardo, it's nuclear safety regulations have been linked to the increasing cost of nuclear energy. Not the only factor I know. Are these safety regs too burdensome? Is there scope for more flexibility, loosening, or do we just need to accept these very high standards? Katrin, you knew I was coming to you on this one.
Sorry, can you repeat that? Sorry.
Okay. Nuclear safety regulations have been linked to the increasing cost of nuclear energy. Not the only factor.
Yeah, you know. Sorry, just seen it. Yeah, so historically we have put huge conservatisms in the designs of components, and of course the plants of things we've got, a lot of them we've got now were designed some decades ago. but we've learned a lot in the process, and we've learned from past operation, and we have sort of completely got new modeling tools, and we've got a lot more experimental tools. So moving forward to the future, we can sort of optimize designs a bit more, which will reduce cost and to some degree reduce conservatism. But of course, we don't want to compromise any standards in that.
Okay, yeah, good. That's a very important point. It's one of those things that, again, if I just mention SMR, sorry about this. One of the proposed advantages of SMRs is that you're building many of the same thing, and that gives you experience of running the same thing, and that plays into that reduction of conservatism, because it is very true that there are some fairly extreme costs associated with the safety regulations, but some would point out that given what can happen, that's entirely reasonable. Okay, I had another one. This really following on, would the international community need to set and regulate standards for the safety of nuclear plants and ensure that these are respected worldwide? Does anybody want to answer that? Maria? So I'm putting you on the spot here.
Sorry, I'm just rereading the question.
Yeah.
Would the international union set and regulate standards? I think after a discussion I had, I think a couple of weeks ago, with Mike and one of his colleagues, it's whether, in terms of the international community, I think when it comes to nuclear, one problem that engineers and scientists face is the politics behind it. So in my opinion, it's whether or not, it's very much based on I think the international community coming together and setting standards is quite a politicized problem, I'd like to say. From my understanding, most of the time, the engineers and scientists are the ones that specialize in advising. So, I mean, there are organizations that try to regulate this, like the IAEE, I believe. But I think in terms of the international community coming together, that's very much based on the politics.
Okay. that was quite an unfair question, but in the last my last intro to nuclear energy lecture was about safety regulations, so I just wondered how much of that might have got in. Okay, right. We have another question arising. So one, this is sort of synthesis of questions, but one method of countering the intermittence of wind and solar is to overbuild them by a factor of 2 or so. With the current price difference and other issues, can nuclear compete with this? Anybody want to take that?
I'll sort of say a few words on it. There's his data is available for use of how much wind's been available for sort of years. It's freely available, and of course, if you're looking at wind, for example, or solar, there are times when none is available. So it doesn't really matter if you plaster the country with sort of wind turbines, for example. Weather is usually very similar across the UK. Apart from some small differences, of course. So if there's very little wind, it doesn't matter if you double the capacity. you're still going to get insufficient energy.
Yeah, I think that's the issue, and I think often one of the discussions on the intermittency issue is about the lengths, the time scale of the intermittency. So the short time scale intermittencies, and maybe batteries and other sources can help with that. And there are quite long-term intermittencies, you know, the seasonal intermittencies, and then there are the really annoying bits in the middle, the 4-day lull. We're sort of in one now, and if you look at Germany, it's currently its wind is about 15% of capacity. Solar is at about 10% of capacity. If you build twice as much or so, that hasn't changed the game. So yes, to a degree, but again, I think where the difficult position is, if somebody wants to say this technology is the answer, and if somebody says this technology is the answer, that you know, I think it's a mixture of technologies that do that. Okay. Okay. So where are we? We're not far from the end, so I want to pick up a few. It's all right. I'm just scrolling up and down. Okay. So. Mercedes, one for you. What are the risks that come to mind with the use of nuclear power? In general.
I'm trying to think back to all the different courses we've done. So a lot of the time when we're given courses, they're about safety or policy making and things like that to do with nuclear. And I think something I've probably taken away is that nuclear is a lot more safe. I didn't have a nuclear background before starting, and nuclear is a lot safer than I ever thought it was, and a lot safer than I know a lot of people that I talk to think it is. People have a really negative conception of what nuclear is and what nuclear does, and I think that's a risk with the use of nuclear power, that there will always be people that will be opposed to it, and therefore promoting nuclear power and increasing the size of the nuclear power industry that we have, that is kind of one of the biggest risks, is actually getting the support behind, whether it's political, but more importantly public. In terms of using nuclear power, it is very safe. And every time there's an incident or a near miss or something like that, people learn from it and improve the system and make it safer. So for me, that isn't kind of a risk that comes to mind. I guess then it's things like long-term waste storage, and there isn't a lot of waste, but it's, again, an opinion that people have that it's really unsafe and it's going to destroy the world, and it's really not. Everything's managed safely, and I think it's just making sure that we make it clear that we can manage everything safely and securely, and we are doing the optimum we can to make it so that nuclear is extremely viable at any scale and using any type of nuclear power.
Yes, I think if I could chip in, it's a fairly recent change, but I think amongst the concerns over global warming and emissions, and also the toxicity of fossil fuels and the toxicity of various other things that aren't normally appreciated in renewables, there's now, I think, an increasing understanding that there is risk, and it's not just nuclear power is a risk and everything else is fine. We plainly and now know the numbers that we are taking risks by doing nothing. And I think that in terms of this where next for nuclear, I think that the concerns over risk that are normalized in nuclear and are part of very much of the game, I think that is also now starting to be applied to our current energy generation, with a realization that you know, there is always risk, and what wasn't perceived as a risk in the past now is. So thanks for that. I have let me just see. another question on a slightly different one. If I can ask, maybe this is one for Tom. What is the appetite for policymakers and especially international investors? Because I know that you're looking at the economic side, but generally on fusion, but let's look at fission as well, including public institutions such as the World Bank and so on, as well as sovereign wealth funds on investments in nuclear energy. Have you got sort of?
Yeah, sure. I can do my best to answer that question. So appetite for policymakers and especially international investors. So if you're looking at the future of nuclear energy, you only need to really look at the kind of the gas prices that have occurred within the last couple of months to see that you need some other alternative in some respects of where people can get their power from. Also, obviously, we know that the phase out of fossil fuels that have been talked about, or the phase down, especially of coal as well at the recent COP. So with reactor, well, it's in fission with the introduction of kind of small modular reactors that are looking like they're going to take less time to build, be more available to fit into a kind of decentralized energy grid where you don't just have a big power plant supplying energy and then distributing it around to the UK. You can have it in little pockets, and it's available to match demand. That kind of appetite will probably only grow, but you have to, and a lot of things that come into this is that public perception, and that's really important. I think we've talked about it previously about how you can educate the general public on the actual safety that comes into nuclear power, because of the accidents that have happened in nuclear in the past, Chernobyl and Fukushima being two notable ones. It's probably the most regulated source of energy that exists. And that's the reason, partly why it's so expensive, but it also makes it some of the most safe. The UK understands the most, probably arguably out of most countries, about nuclear safety, about waste regulation, how you can treat waste, and so as long as you kind of you can combat that negative public perception that comes in, I think their appetite will only grow, and especially in some nations that maybe haven't got so much of a baseload of nuclear at the moment, but will probably look to have one in the future if they're phasing down on their fossil fuel consumption, especially in places like China.
Okay, thanks, Tom. We're into our sort of last 5 minutes, so I've been told I should be looking to wind up. I've got a few closing remarks. I just wanted to come. I apologies if we haven't answered all your questions. It's not the fault of the panel or the production team. I'm afraid if we haven't answered your questions, it's entirely my fault. I'm going to pick just a few closing ones because I think they're quite interesting questions. It's one from Shmuel. How the development of nuclear energy can support the resolution of social problems. Okay, just as one last one. Anybody want to say anything to that? I've got a few thoughts. I always have. One thing that I would say is as we've seen, if we don't address the intermittency and the security of supply, the first people that struggle are the poorest, because rich people will pay more for what is there. Okay, so security of supply is an important thing. It's when it comes to social problems. It's a very good question, because if the first thing that happens, as you see when there's an issue of security of supply, as we saw with gas, is the price goes through the roof. And it's poor people who suffer. So given that one of the main social problems globally is poverty, I think nuclear power does have a role to play. Right, so I think we're almost there. I need to say a few things. Again, apologies if we haven't answered your questions. I will stay online. The Future Energy Festival continues shortly with a series of lunchtime lightning talks and demonstrations on a variety of energy related topics, including redox flow batteries, structural power composites, and Britain's energy under lockdown. Please follow the link in the Q&A to join the next session. After lunch, we'll have another panel discussion, this time on designing future energy systems. That starts at 2 p.m. and the link is also in the chat. And you can find full details of all the Future Energy Festival events on the Energy Futures Lab website. The details are on the screen. And I hope we've addressed as well as we can your questions, and I hope you enjoyed it. I know I did, and I'd like to thank the other panel members for their contributions. Okay. I think I'm a bit early.